Hello everyone, good evening. So here we shall solve from question number 52 onwards. So here it is given that the bisectors of angle D and angle C of triangle ABC meet at I. And IP is perpendicular to BC and IQ perpendicular to CA and IR is perpendicular to AB. Then we have to prove that first part is IP equals to IQ equals to IR. And second is IA bisects angle A. IA bisects angle A. So then the proof is that so here we will say now in triangle EIR and triangle BIP, we have angle IBP that is equal to angle IBR. Angle IBP is equal to angle IBR. Since the reason is that since it is given that since IB is the bisector of angle D is given and angle IPB that is equal to angle IRB is equal to 90 degree Angle IPB is equal to angle IRB which is equal to 90 degree. Since it is given that IP is perpendicular to BC and IR is perpendicular to AD. This given. IB is the common side. IB is the common side. So therefore, two angles and the non-included side are equal in these two triangles. So therefore, I can say that triangle BIR is congruent to triangle BIP by AAS rule of congruency. AAS rule of congruency. So now, therefore, we can say that IP is equal to IR. You can say that IP equals to IR by CBSE. Similarly, you can say similarly in triangle IP triangle ICP and ICQ. In triangle ICP and triangle ICQ, we can see that angle ICP equal to angle ICQ, angle ICP equals to angle ICQ. Since why? Since as you can see, IC is the angle bisector of angle C. Since IC is the bisector of angle C. And IC is the common side. IC is the common side This is the common side, and IPC is equal to IPC. Angle IPC is equal to angle IQC, which is equal to 90 degree. Since why it is given that IP is perpendicular, since IP is perpendicular to BC and IQ is perpendicular to AC, which is given. So therefore, I can say that triangle ICP. So here you can see that we have told that two angles and one non-included side is of these two triangles are same. So I can say that triangle ICP is congruent to triangle ICQ by AAS rule of congruency. So therefore, you can say that so IP equal to IQ, IP equals to IP by CBSE. So if we combine these two, then therefore we can say that IP equals to IQ equals to IR. So hence the first part is proved. Therefore, this first part is proved. And then we can take the triangle AIR and AIQ. Now we can say now in triangle AIR and triangle AIQ, we can see that AI is the common side. AI is the common side. And we can say that IR is equal to IQ, which is proved earlier. IR is equal to IQ, which is proved above. And we can say that angle ARI is equal to angle AQI. Angle ARI is equal to angle AQI, which is equal to 90 degree. This since it is told IR is perpendicular to AB, since IR is perpendicular to AB and IQ is perpendicular to AC. IQ is perpendicular to AC, which is given. So we can say that so triangle AIR is congruent to triangle AIQ. How? Why? Here we have taken the right angle and the hypotenuse is common and one side. So therefore, these two triangles are congruent by RHS rule of congruency. RHS rule of congruency. So therefore, we can say that angle IAR is equal to angle IAQ. Angle IAR is equal to angle IAQ. How? By CBCT. So hence we can say that so IA is the bisector of angle A. So hence IA bisects angle A. So hence proved. So the second part also has been proved. Then here it is told in the given figure 53, ABCD is a quadrilateral. ABCD is a quadrilateral, and E and F are points on AD and CD respectively, such that AB equal to CB, AB equal to CB, and angle ABE equals to angle CBF, and EBD equals to angle FBD. So prove that BE is equal to BF. This is a quadrilateral. So now it is given that in quadrilateral ABCD, E and F are points. E and F are points on AD and CD. AD and CD respectively, such that AB equals to CD. AB equals to CB. And angle ABE equals to angle CBF. And angle EBD, that is equal to angle FBD. We have to prove that BE equals to BF. So the proof is, first we need to prove triangle ABD and CBD are congruent. So we will take in triangle ABD and triangle CBD, triangle ABD and triangle CBD, AB equals to CB is given. And we can say BD is the common side. BD is the common side. And angle ABD plus angle ABD equal to angle CBF is CBF plus angle FBD. Since why it is given that these two angles are same, so if we add them, then their sum will be also same. So this implies EBD plus ABE, that is equal to angle ABD. The angle ABD that will be equal to angle EBD. In CBF plus FBD, that is CBD. So it means that two sides and their included angle in between these two sides, that is same in both the triangles. So therefore, I can say that triangle ABD is congruent to triangle CBD by SAS rule of congruency. SAS rule of congruency. SAS rule of congruency. So now, therefore, we can say that before angle BAD, angle BAD, that will be equal to angle BCD by CBCD by CBCD, which means that angle BAE, that is also equal to angle BCF. So now we can take triangles ABE and CBF. Triangle ABE and triangle CBF, ABE and CBF, we have that angle ABE is equal to angle CBF, angle ABE that is equal to angle CBF, right, is given, and angle BAE that is equal to angle BCF, which has been proved earlier, or I can say it is proved above. And the two sides are equal. AB equal to CB, which is given. AB equal to CB, which is given. So therefore, I can say that triangle ABE is congruent to triangle CBF by ABE is congruent to CBF. ABE is congruent to CBF by ASA rule, by angle side angle, by ASA rule of congruency. By ASA rule of congruency. A is a rule of congruency. So therefore, we can say that B is equal to BF. Therefore, we can say BE equals to BF. E equals to BF. Right? CPCT. Then question number 54, it is told that X is equal to Y and AB equal to CB, then prove that AE equal to CD. It is given that here we can say that AB, I can say that AB and CB are two arms of angle B, two arms of angle B. And CD is perpendicular, CD perpendicular to AB, and AF, AE, yeah, and AE is perpendicular to AB and CB are two arms of angle B, where CD is perpendicular to AB and AB is perpendicular, AE is perpendicular to BC. And we can say that CD and AE intersect at F. CD and AE intersect at F. Where I can also say that angle AFAEC, that is equal to y degree, and angle ADC, that is equal to x degree. Okay, so this is not perpendicular. Simply we can say that here we can simply say that AB and CB are two arms of angle B, where C and D are points. C and D are points on, or I can say, sorry, D and E. E and D are points on BC and AB. BC and AB respectively. BC and AB respectively, where CD and AE intersect at F, where angle AEC equals to y degree and ADC equals to x degree. And we have to prove, and it is also told that AB equals to CB. AB equal to CB. And we have to prove that AE equals to CD. AE equals to CD. The proof is, you can take triangle x degree equal to y degree. It also has been told. It means that angle AEC is also equal to angle ADC. So it means now here you can see that angle EDC, that is equal to 180 degree minus x, and angle the reason is that since angle ADC and angle BDC forms the linear pair, right? forms a linear pair, so their sum should be 180 degree. Similarly, angle, and we can say angle D AEB, that is also equal to 180 degree minus y. Since we can say angle AEC and angle AEB, and angle AEB forms a linear pair. And also it is told that x equal to y, it is given. So we can also say that angle BDC, that is equal to angle AEB, which will be obviously, since both are equal to 180 degree minus x degree. So now you can say, so now in triangle ABE, and triangle ABE and triangle CBD, ABE and CBD, you can see that angle ABE, that is equal to angle CBD. Sorry, CBD. Angle ABE, that is equal to angle CBD. Since why? The reason is that since angle B is common. Angle B is common. Angle B is common. And AB equal to BC, AB equal to CB, AB equal to CB just being given. And angle AEB, that is equal to angle CDB. Angle AEB, that is equal to angle CDB or BDC. Since why? It is proved earlier, or proved above. It is proved earlier here only. So therefore I can say here, so we have taken two angles. We took two angles and the non-included side. Took two angles and the non-included side. So it means that triangle ABE is congruent to triangle CBD by AAS rule of congruency. The AAS rule of congruency, since we have taken two angles and the non-included side. So I can say that AE equals to CD. I can say that AE equals to CD. AE equals to CD by CPCD. So hence proved. Then in question number 55, it is told ABCD is a quadrilateral such that diagonal AC bisects the angles A and C. Prove that AB equal to AD and CB equal to CD. So here we will draw one quadrilateral. CD. So here AC is told AC bisects angles A and angle C, and prove that AB equals to AD and CB equals to CD. Now it is given, you can say that given, I will say that AC is the diagonal of quadrilateral ABCD, which bisects the angles, angle A and angle C. then we have to prove this asks to prove that AB equals to AD and CB equals to CD. AB equals, so of the proof is that I will say that in triangle ABC and triangle ADC, angle EAC, angle BAC equals to angle DAC. Since why it is given? It is given that AC bisects, well, that AC bisects angle A. Similarly, I can say that an angle BCA, that is equals to angle DCA. Since it is given that since AC also bisects BC, and we can see that AC is the common side. AC is the common side. So therefore, we can see that we have taken two angles, and the included side of these two triangles are equal. So therefore, I can say that triangle ABC, that is congruent to triangle ADC. The reason is I A is by angle side angle, by A is a rule of congruency. A is a rule of congruency. So I can say that AB equals to AD, AB equals to AD, and BC equals to BC by CBCT. No, hence proved. So if all of you understood the solutions of these questions, still any doubts, please write that in the comments. We shall obviously 35 then. So thank you everyone. Bye.